Okay, here we're given the graph of a degree 3 polynomial. We know it's a degree 3 because if we were to multiply each factor, x times x plus 1 times x minus 3, we would end up with an x cubed, which is a degree 3 polynomial. Now, in a degree 3 polynomial, we know that the end behavior is going to represent or look very similar to an x cubed, in which the left end is falling and the right end is rising. So what's going to happen here is we're going to first need to find the x-intercepts and the y-intercept. So the x-intercepts are the value of x when y is 0. So we have 0 equals x times x plus 1 times x minus 3. Now I'm going to use the zero product property, setting each variable factor equal to 0, and I get my x-intercepts of 0, -1, and 3. These are called zeros, which are also called roots. And when I put them in ordered pairs, 0, 0, -1, 0, and 3, 0, they are now x-intercepts. So I'm going to plot those x-intercepts, 0, 0, -1, 0, and 1, 2, 3, 0. So we have intervals. We have from -infinity to -1. What's happening between -infinity to -1? We also have the interval from -1 to 0. We have the interval from 0 to 3, and then we have the interval from 3 to infinity. So we've got 1, 2, 3, 4 different intervals that we need to do some test points on. Now, if I go to the left of -1 on the x-axis, and let's say I choose -2 as a test point. So here's -2 right here. If I put a -2 in, x is -2. X plus 1, my next factor, is -2 plus 1, which is -1. And -2 minus 3 is -5. So overall, I have a negative times a negative times a negative, which is a negative, and then multiply 2 times 1 times 5, and I get 10. So when I put a -2 in, I get -10 out. So -2, -10. Let me show you. -2, that's my -2, and here's my -10 overall. So you can see where those numbers are coming from. Okay, so what's happening to the left here is that our graph is falling. Let me do this in gray. So our graph is falling to the left. So what's happening in between -1 and 0? Well, in between -1 and 0 is -1/2. So I'm going to put a -1/2 in. And when I put -1/2 in, x is -1/2. -1/2 plus 1 is +1/2. And -1/2 minus 3 is -3.5. And -3.5 is -7/2. A negative times a negative is a positive, and that's going to be a positive 7/8. 7/8. 1 times 1 times 7 is 7. 2 times 2 times 2 is 8. So when we put a -1/2 in, we are going to get a positive 7/8 out. So -1/2, positive 7/8. That's going to turn like that. Now I need to pick a point in between 0 and 3. In between 0 and 3. I personally like the number 1. 1 is a nice number to put in. So I put a 1 in. 1 plus 1 is 2. 1 minus 3 is -2. So 1 times 2 times negative 2 is negative 4. 1, negative 4. 1, 2, 3, 4. So we're coming down like this. I have a feeling it's going to drop down a little bit more. So I'm going to put a 2 in. When I put a 2 in, remember my factors, my equation. I'm going to put a 2 in. 2, 2, 2. I'm going to get 2 times 3 times negative 1. I'm going to get a negative 6. So when I put a 2 in, I'm going to get a negative 6 out. And we know it's going to turn back up because it's got to go through this x-intercept. Now my last point, I'm going to pick a 4. So I need to pick something in between 3 and infinity. That means x is 4, x plus 1 is going to be a 5, x minus 3 is going to be a 1, and I get a 20 out. So when I put a 4 in, I get a 20 out. So this is really steep, really super steep. It almost looks like it's vertical. It's moving to the right slightly and spiking up. And that is our polynomial function, y equals x times x plus 1 times x minus 3. So that's what the graph looks like between the x-intercepts. Many times we just do a lot of the work that I showed you here in this table format. We do a lot of this in our head. Sometimes we don't even look at the numbers as much, we just look at the signs. S-I-G-N-S. We look at the signs. Are we going to have a negative output or are we going to have a positive output? Okay, so let's kind of put it all together and see if we can recall how many turning points we have and the lowest possible degree that we would have. So for instance, this was a degree 3 and we had 2 turning points, right? 2 turning points. 2 turning points means the lowest degree it could be is a 3, because whatever your degree is, you're going to have at most 1 less number of turning points. So let me draw a picture for you here and I'll tell you what I'm talking about. So it kind of looks like a step. I could draw it like that, or I could draw it like that. I'm trying to draw a real cool one here, if you couldn't tell. There, that's kind of cool right there. Okay, so this has 1, 2, 3, 4 turning points. That means the lowest possible degree that this can be is a 5. It could be a 5, it could be a 7, it could be a 9, it could be an 11. It could be any odd degree, 5 or higher, but the lowest degree it can be is a 5. The reason why it has to be an odd degree, remember what you learned about the end behavior. Odd degrees, the ends are doing different things on a polynomial function. One end is falling and one end is rising. That's what's happening here. Okay, let me try and draw another one. Okay, so let's look at this one. 1, 2, 3, 4, 5. This has 5 turning points. That means the lowest degree it could be is a 6th degree. So it could be a 6th degree, it could be an 8th degree, it could be a 10th degree, a 12th degree, and so on. But the lowest degree it could be is a 6. It can't be any lower than 6 because it has 5 turning points. Okay, there's that graph right there. How many turning points does it have? Yep, you are correct. It has 1 turning point. That means its lowest degree is a 2. It could be a 2nd degree, or a 4th degree, or a 6th degree, or an 8th degree, or any even degree thereafter, but the lowest it could be is a 2. Its a lowest degree is a 2. So if you have an odd number of turning points, an odd number of turning points equals an even degree polynomial. And an even number of turning points, so if you can recognize your graph's turning points, an even number of turning points means an odd degree polynomial. So there's a little bit about our graphs right there. In the next, we're going to make sure you have your graphing calculators out, because we're going to look at the graphs of x squared, x to the 4th, x to the 6th, x to the 8th. So we're going to look at these even degree polynomials. We're going to look at the odd degree polynomials, and we're going to compare them. Okay. The other thing that we're going to do is we're going to talk about that end behavior for polynomials. So we've talked about it. I've talked about it. I referred to it. Now I'm going to kind of give you a formal definition of it, just in case you don't quite remember it or have a strong grasp.